to today's webinar with the title PCB Technology, Solder Surfaces. I'm Andreas Schilp, your host and your speaker in this today webinar from Würth Electronic Circuit Board Technology. I'm the speaker actually, but I have an excellent specialist beside me, Bernd Schröder, who will help me finding the correct answers for your questions and who also contributed in the content and the presentation for this webinar. So the agenda you can see here. We will talk about an introduction. We'll have an introduction into solder surfaces. Let's have a look at the world market update. We will talk about the development of solder surfaces in the past until today, and we will have a detailed look into the most important surfaces. We will then have some hints for selecting the best fitting solder surface, and we will give an overview with recommendations for various applications. Finally, outlook and summary. So a small hint into our portfolio. We offer from basic up to embedding technology, a lot of different technologies from sample, one piece, up to large series from Asia. So if you need PCBs, please join us and come to us. There's an I missing, but I think we can read it anyway. Introduction to solder surfaces, world market update. Small hint at this point, we will not talk about wire bonding technology in detail and contact surfaces like polymer surfaces. So this is not content in this presentation. So now this is the look at the spread of end surfaces worldwide, and we can see that big share of surface worldwide is OSP. This is due to the high volume of commodity electronics, which fits perfect for these easy applications and not that much demanding field conditions. The next is Immersion tin and ENIC and some others. And on the right side you can see how the trend is over the last 4 years. So ENIC, ENIPIC rising slightly. Most remarkable is the decrease of hot air solder leveling. So this is also why the sustainability aspects are more and more interesting and important, of course. And on the other hand, hot air solder leveling does not fit well for small components and fine pitch applications. So that's why hot air solder leveling decreased 6.5% over the last 4 years. So now let's have a look inside at the spread of end surfaces at Würth Electronic. So here we can see that the major surface is ENIC with more than 70%, followed by Immersion tin, hot air leveling lead-free, some hot air leveling still leaded for special applications, security applications and things like that, but still used, and Immersion silver. So we can see that the trend shows a clear rising from of Immersion tin, and same picture here for hot air solder leveling or hot air leveling decreased by more than 6% over the last 4 years. So let's have a look at the development of these solder surfaces over the last decades, and we can see that all began with reflowed tin lead in the 60s of the last century. Then more and more solder surfaces were developed and added here in this overview. And today there are around about 13 surfaces, of which 11 are still active. The surfaces with the orange color are generally also bondable surfaces, but that's not the focus today. So unfortunately, one solder surface didn't it into high volume application, that is DIG, which stands for direct immersion gold. So that was a promising development, but finally complicated, expensive, and unfortunately no longer available. So let's have a closer look at the most important surfaces in detail, and we are starting with OSP, which stands for Organic Surface Protection. So this is a small thin film over the copper surface, and as the reason for all the solder surfaces is to prevent oxidization from the copper surface. This is one simple possibility to prevent oxidation from the copper surface by adding an organic coating over this. So the layer thickness is 0.1 up to 0.6 micron thickness. So we can see that the storage time is not that long. It's just 6 months, and another disadvantage is the limited number of high temperature processes. So normally after a single solder process at a high temperature, solder temperature, removes the organic coating, which means now the oxidation can start at the copper surface. So you have to care about the further processing and storage, and as well the application in the field needs protection of the pure copper surface. So maybe it could be coated by tin during the soldering process. Otherwise you would have a pure copper in the field, which is not that good concerning reliability issues. On the right side you can see colored boxes with different criteria. Everywhere we see red, that it's not that perfect or not possible. Green means excellent, so OSP has an excellent ROS compliance, and could be used for fine pitch application. It's also good for high frequency applications, and rework is possible, and the costs are pretty good for this surface. But for industrial application, and we have a lot of industrial and automotive high-tech applications, we cannot use this in high volume. So that's the reason why we don't offer today OSP, but times may change. So let's continue with the next solder surface, which is ENIG, which stands for Electroless Nickel Immersion Gold. You can see the details here. There's a nickel barrier between the copper and the gold to prevent diffusion of gold into the copper. And then finally we have a thin gold layer. We have a storage time of 12 months. A lot of applications possible. Good known advantages: very planar surface, long shelf life, very versatile in use. But on the other hand, we have of course also some disadvantages. It's finally expensive. And nickel is not suitable for high frequency, and as well medical applications often do not want to use nickel or cannot use the nickel. So nevertheless, this is a good surface and very widely and high volume used. And again, you can see on the right side, you can see the same structure of the rating regarding the different categories. It is rust compliant. You can do multiple soldering without problems. You can also use that surface pretty good if you have to dry PCBs prior to soldering, maybe rigid or RIGID.flex or flexible PCBs which have to be dried. So the accelerated aging due to the drying process does not harm this surface any at all. So that's a good issue if you have to dry. Okay, now let's have a look how the process is for the application of Electroless nickel immersion gold. On the left hand you can see the line we have in our plant in Niedernhall, and on the right side at the bottom you can see the racks where the production panels are placed in for the process. And we also have a small video. We can see along the process here, you can see bubbles. This comes from the nickel deposition process. So it's a complicated process, and it's also relatively expensive. We have 30 individual steps. We are using ultra pure water to prevent contamination of the bath and also ensuring a high purity surface quality, thus minimizing ionic contamination. So that's it for the anic process. Let's have a look at the next solder surface, which is hot air solder leveling, or hot air leveling, also called mainly in the German areas. The description says that it's a traditional process with molten lead-free tin on the copper, and it's applied with the molten tin. We also can see a video shortly. So we have a thick layer which enables an easy soldering process. We have solder deposit on the pads for the soldering process, which helps in the soldering process. We have long shelf life. It's relatively inexpensive, but of course it's a high stress for the material. We have an uneven surface. It's not fitting for fine pitch applications. There's also some copper dissolving in this process, so we have to start with more copper in the through-hole platings if you want to do a hot air solder leveling process. So this is an additional cost aspect adding to the costs for this solder surface. And yeah, finally it's not bondable. So let's have a look at the process. On the left side you can see a typical picture of a hot air solder leveling surface. You can see the solder hilts at some parts of the pads, so that's absolutely typical for this surface. And now let's have a look at the process. So that's prior to the application of the tin. There is of course a cleaning process. So now there's a handling system taking the panel and then dipping into the liquid solder. Next thing we can see is the removal of the solder. So it's slabby, very hot, and afterwards it has to cool down again to room temperature prior to the cleaning process. So here we can see the next panel coming. So here it is, next panel directly from the hot solder, and the next thing is there is hot air around about 400 degrees C, which blows away the tin which is not needed for the surface. So that's hot air solder leveling. The hot air is to remove the tin which is not needed. But this leads to high thermal stress and as well for the uneven surface, as we have seen. Okay, let's have a look at immersion tin. Again, this is tin, but not applied by dipping into liquid solder, but do it in a chemical process, immersion tin. So the thickness is smaller than with hot air solder leveling. We have round about 1 micron. The storage time is reduced to around about 6 months. It's an excellent planar surface, also possible for fine pitch applications. The disadvantage is the limited shelf life, of course, and the limited number of high temperature processes which could be applied. But it's a fine process, fine solder surface at all, and it's of course a little bit sensitive regarding the shelf life. That means we have a intermetallic phase between the copper and the tin, so reduced by this process the tin thickness is reduced over time, so you have to regard this in your planning. It's as already told, it's an immersion process and chemical process, a horizontal process. We will see that in a minute when we see a video of the process itself. So we have finally a complex process, multi-step process. We have to prevent oxidation, and we have to care for the thickness, layer thickness control. So here we can see the process. It's a horizontal process, and here on the video we can see how the production panel moves into the process. And so how long do it take for the process, Bernd?
16 minutes.
16 minutes is the process time in this line until the deposition of the immersion tin has finished. Okay. So the next solder surface is immersion silver. So we replace tin by silver, and this is a even thinner surface. The layer thickness is 0.12 up to 0.3 micron. The storage time could be 12 months, but for that you need a special packaging. We will see that later on. It's affordable, it is flat, it's nickel-free, but you have to care for the packaging, the storage. So everywhere you have sulfate in the air, it's critical. But it's also, it could be used for high frequency application and a lot of other applications, but it's not that spread today. So in the past we had more applications using immersion silver, but today we don't have that high volume anymore. So this is a general overview showing all the categories and our ratings for all the solder surfaces we have talked about already. We also have ratings for NEPIC, which has another layer in between nickel and gold, which is palladium. And we also have ratings for soft gold electroplated and hard gold also electroplated. So just to summarize all the ratings on one view. So how about selecting the best fitting solder surface for your application? There are different requirements you have to care for, which means the process for the application of the solder surface, as well as the process for the further application of for the soldering, for the costs which are implemented in these processes, and of course also the environmental compatibility. So harsh environments, of course, could be a problem, but this is reliability on the right side. So as well, thermal resistance of the materials, long-term stability and shelf life. Functionality, there could be restrictions or requirements coming from the layout or from components, which mainly needs a flat surface and compatibility with fine pitch design. And last but not least, joinability, which means how could be the soldering performed, or wire bonding, or maybe conductive bonding, or maybe press fit. So how is the joinability between components and PCB? So just to give you some requirements in an overview. And here are the requirements for the solder surface in a different way. So maybe you need high frequency, or you have mechanical requirements. Of course, costs are always important. Disposal costs, on the other hand, have to be regarded. Maybe it has to be nickel-free, or you have to perform a drying process, as already mentioned. If you have flex or RIGID.flex PCBs, you have to care for the storage between soldering processes. Maybe you have press fit technology, or wire bonding, or you need contact surfaces. So here you can find a lot of requirements. And now we try to provide a quick select sheet here. Maybe you need lead-free, so you can see in the second row the possibilities which meet the requirement lead-free. Maybe you need a solder surface with a low budget. Then if this is very critical, we have OSP in this row. We have OSP, we have hot air solder leveling, but that needs to meet all the other requirements, of course. We have the possibility of immersion tin or immersion silver. So this is an attempt an approach to give you some ideas for a quick select, but of course you have to dive much more deeper into the subject to find the best fitting solder surface. So let's talk about another topic which we called known risks in the field. Of course, there must be some questions from your experiences. And for hot air solder leveling, for example, we know a yellow effect, we know wetting problems, or layer thickness too high. So there are some restrictions for this solder surface, but all in all, the hot air solder leveler is a very robust and affordable solder surface. Immersion tin, from immersion tin we all have heard about whisker formation, which comes from the mechanical stress inside the grains of the tin. So without any current or voltage from outside, that could happen even in the storage area. That's not fine, but you have to know this. If you apply temperature to the board, the whiskers will disappear. But if whiskers break and come and produce a short, that might be critical. So other things which are known from immersion tin are undercut, leading to interruptions, mouse bites, and storage. So how can we provide these failures, Bernd?
Mouse bites?
Yes, mouse bites and mouse bites.
Mouse bites is a defect of the copper, small copper in a hole. Yeah. Copper thickness is too thin.
If you have too less copper thickness in holes, then we can have mouse bites.
Yes.
After the application of the immersion tin solder surface. Okay, so that's more or less our problem. Yeah. So it's a problem of the PCB manufacturer, not for the further processing of the boards. So let's have a look at immersion silver. Creep corrosion could be, is known on the market, could happen. Oxidation is not that a big problem. Oxidized immersion silver could be soldered finally. It's more critical if we have sulfide in the air than if we have silver sulfide. Then it's not possible to solder this surface anymore. And of course, reduced storage and maybe special packaging for that. ENIC or similar surfaces, there's the keyword black pad. So this was mainly the first generation of this solder surface. Today we are talking about the second generation of ENIC, and we personally in our company we don't know the failure of black pad with our products. So we haven't had black pad over the past years at all. Okay, so black pad comes from nickel corrosion, but we don't know that. OSP, we have certain limitations we already talked about. Hard and soft gold, that's not the main topic of today, but of course, if you have a lot of gold, that's not fitting to soldering process as if too much gold solves in the solder, it makes the solder brittle and it's not reliable anymore. So, but that's side topic, let's say. Okay, soldering and drying remarks. I already mentioned flex and flex rigid PCBs, which must be dried prior to the soldering processes and also prior to reworking processes, hand soldering and things like that. So that means drying means exposition to higher temperature, normally 120 degrees, which has an impact on the shelf life of the solder surface. So it's an accelerated aging finally, and you have to care that you don't exceed the shelf life. So if you are waiting, for example, with immersion tin, you're waiting 6 months until you start drying the PCBs. That's for sure not optimal and may be critical, as the following drying process at high temperature even alters the solder surface even more. So you are exceeding the shelf life of 6 months, which is critical. So if you have to dry, we also had a webinar on this topic, drying process. You may have a look at our website or on our YouTube channel, and you can read a lot about the process of drying itself. So intermediate storage, if you have several multiple soldering processes, there might be the need of an intermediate storage. And out of our experience with the immersion silver, we know the so-called intercept technology, and just a hint for you, that might be a possibility to make a good storage prior to the next soldering process, and preventing massive oxidation from the surrounding air. So, of course, the negative thing is you have additional initial costs, but what we could experience is that this is a very nice possibility preventing oxidation for PCBs and maybe also partially assembled PCBs. Of course, there are challenges of the future. We already talked about sustainability, about costs, about design requirements, very high density design. And here you can see on the picture, you can see the principle of Electroless nickel gold, where we have around about 5 micron thick nickel layer. And if we look at 2 adjacent pads in this cross-sectional picture, we can see that the distance between the two, so the spacing between the 2 pads is reduced by around about 10 micron, which hurts a lot if you want to have a very high density design. So we are sure that in the future we certainly will no longer be able to afford this in the future. So we must find alternatives in solder surfaces, also regarding this special aspect. But we also see the cost development of gold, which is a very good metal, but a very expensive one, as you can see here. And so this is the development of all the surfaces, or the cost comparison, let's say, of all the different solder surfaces here. Just to get an idea about the relation between different solder surfaces. And the next slide is what I actually talked about. This is the price of the gold metal itself and the development over the last 5 years. So this is crazy and makes the PCBs even more expensive if we need gold to prevent oxidation of the copper prior to the soldering process. So definitely we will need some alternatives and new surfaces. So we expect in the coming years more environmentally friendly and energy efficient methods for coating PCBs. And we will see stricter environmental regulations. We will need increased material efficiency, more use of eco-friendly coatings, and as well circular economy and recycling processes. So that will be more and more important, and we will keep in touch and inform you about further developments and possibilities. But that's it for this webinar, and thank you for participating.